Good day to you all. Now let us discuss an interesting topic of Hooke's law. When a force is applied to an object, it could cause to compress, stretch, or to bend. This change could be easily observed in case of spring, but it is valid for other materials too. The changes in the shape of an object is termed as deformation. Deformation can be classified into two types: elastic deformation and plastic deformation. Elastic deformation means if an object returns back to its original shape after the removal of force, it is called as elastic deformation. Plastic deformation or inelastic deformation means if an object doesn't return back to its original shape and stays deformed, we call it as inelastic deformation. When an object is subjected to a deforming force, a restoring force is developed in the body, which is equal in magnitude but opposite in direction to the applied force. This restoring force per unit area is known as stress, and the deformation cause is known as strain. Hooke's law is an empirical law. That means the law was derived using observations. It states that for elastic deformation in a spring, the deforming force is proportional to change in length. When we consider a spring of length L, whose one end is fixed and the stretching force of F is applied to its free end, and the extension is denoted as X, the Hooke's law states that the force F is proportional to X. According to the rule of mathematics, when one quantity is proportional to the other, we can equate both by including a constant. So F deformation is proportional to X can be written as F deformation equal to Kx, where X is the magnitude of spring extension, F is the magnitude of the applied force, and K is the spring constant. When Hooke's law is stated in vector form, the equation becomes F is equal to minus Kx. It means restoring force proportional to the extension. This is valid only in case of elastic deformation. The negative sign indicates that the restoring force is opposite to the direction of the extension x, and the spring constant k is always a positive number. Now let us look at the practical. The aim of this practical is to determine the spring constant k of a spiral spring by using a relationship between extension of a spiral spring and the magnitude of the applied force. Materials needed for this practical: rigid stand, spiral spring, meter scale, weight hanger, and weights. Fix one end of the spiral spring on the rigid stand and hang a weight hanger on the free end of the spring. Now the spring extends and moves downwards. Note the readings on the meter scale and record the readings. Now take a slotted weight and put it gently on the weight hanger. Then it moves downward. Note the readings on the scale. Record the mass load and the readings in the tabular column. Again, place another weight on the weight hanger. The spring elongates further and it moves again in downward direction. Note the scale readings and record the observations.